An arithmetic sequence starts 23, 36, 49, 62, and so on. What is the first term of the sequence to exceed 100,000? So we see that the sequence 23, 36, 36 to 49, 49 to 62, the common difference is 13. So that means we can write down, say d equals 13. So the sequence in terms of n can be written as plus 13n. So you have to add something. 13 times 1 is 13. And you take that away from 23, you get 10. So the sequence is 10 plus 13n. This is our sequence. So if this is our sequence, 10 plus 13n, now we have to find the first term of the sequence that exceeds 100,000. So let's write it down that 10 plus 13n is greater than 100,000. So if that's the case, then 13n would be greater than 100,000 minus 10, and that would be 99,990. So n would be greater than 99,990 divided by 13, and so n is greater than, using my calculator, would be greater than 7,691.5. So if n is greater than this, so the first whole number that n would be equal 7692. So it is the 7692nd term that will exceed 100,000. So if I write the 7692nd term will exceed 100,000. And what is that term? So that term would be 10. We substitute n equals 7692 in the sequence plus 13 times 7692, and that equals 10 plus 13 multiplied by 7692, and that gives me 99,996. And if I add 10 to that, I get 100,006. So the first term of the sequence that exceeds 100,000 is 100,006, and that's your answer.